Okay, here we are in 7.2, multiplying powers with the same base. So you guessed it, our objective, our goal for this movie and this lesson is to multiply powers with the same base. So just to recap, we have a number here and a number here. We'll just call them A and N. So this is our base. And this is our power, right? So power equals exponent, right? So if we want to multiply powers with the same base, so let's say we have a to the n times a to the n, well, all you do, the base stays the same, so the base does not change, and you just do n plus n. So that would be a to the 2n. So when you're multiplying the same base, so a and a, you just add the exponents. So when multiplying the same base, you add their exponents. So that should be in your notes with a star by it. When multiplying the same base, add the exponents or the powers. So, for example, if I have 5 squared times 5 to the 4th, that just becomes 5 to the 2 plus 4, which equals 5 to the 6th. Here's another one. If I have x squared times x to the 3rd, you just add the exponents. So that becomes x to the 5th. A common error is to add these exponents and get x to the 6th, right? Because you see this multiplication symbol and you think, oh, I'm multiplying. But when you're multiplying the same base, you add the exponents. Okay, now you try these 3 problems and see what you get. Just remember, this only works when you add the exponents. This works when the bases are the same, okay? So now let's look at a little bit more complicated. Let's have an algebraic expression, not just a numerical expression. So if we have 4z to the 5th times 9z to the negative 12th, well, you just multiply the coefficients, so we get 4 times 9, and then z to the 5th times z to the negative 12th, all of that. So 4 times 9 is 36, and z to the 5th times z to the negative 12th, so 5 plus negative 12 becomes z to the negative 7th, right? And we never want to leave our answers with negative exponents, right? So this becomes 36 over z to the 7th, right? Because the negative exponent tells me to change the placement of the base. So that's our final answer, 36 over z to the 7th. Let's look at another one. If we have 2a times 9b to the 4th times 3a squared. Okay, so regardless of what the different variables are, when we're multiplying algebraic expressions, we can multiply all the coefficients. So 2, 9, and 3, right? So we get 2 times 9 times 3. And then our variables, a, b to the 4th, and a squared. So times a times b to the 4th times a squared, right? So 2 times 9 is 18, times 3 is 54, and a times b to the 4th, those can't be combined, right? Because a and b are not the same base. And also, when there's no power or an exponent written, it's an implied 1. Okay, that's a given. So we have a to the 1st and a times a squared. So that's a 1 plus 2 and b to the 4th. B just stays as it is, right? So altogether, we have 54 a cubed b to the 4th, right? 1 plus 2 gives us 3. B to the 4th. And there's our answer. So let's have you try a few. What is the simplified form of each expression? And then D, explain how to simplify the expression. So go ahead and do these in your notes and we will go over them in class. So you can also use the property for multiplying powers, which is what we're doing here, with the same base to multiply two numbers written in scientific notation. So I know you've had some experience with scientific notation, and it can be confusing, but once you get it straight, it's really easy. So recall that you can use powers of 10 to make writing very large and very small numbers more convenient. So in scientific notation, you can write any number a times 10, any number as a times 10 to the b power. So a, this number here, has to be greater, the absolute value of it has to be greater than or equal to 1, but less than 10. So remember, whatever a is, positive or negative, its absolute value is greater than or equal to 1 or less than 10. So, for example, if we have 256,000, right? In scientific notation, we're thinking about where our decimal place is. So this is just a whole number, right? So the decimal is technically right there, and we would have like a 0 here if we wanted. So in scientific notation, this is written as 2.56 times 10 to the 5th. So think about it. This is where our decimal place is originally. If you move it 1, 2, 3, 4, 5, it goes right there, right? So we have 2.56 times 10 to the 5th. So that 5th is telling me from this position right here, it's a positive 5. So think about a positive, you're moving it to the right. So when this is positive, you're moving your decimal place to the right to get it to its expanded number. So from 2.56, if you go 1, 2, 3, 4, 5 and put your decimal there and fill in those places with zeros, there you have it, 256,000. So now let's apply it with an example. So at 20 degrees Celsius, 1 cubic meter of water has a mass of about 9.98 times 10 to the 5th grams. Each gram of water contains about 3.34 times 10 to the 22nd molecules of water. About how many molecules of water does the droplet of water shown below contain? So rather than converting these to their expanded form, like I just showed you in the previous section there, let's just multiply them in scientific notation, right? So here we have the volume of one droplet is 1.13 times 10 to the negative 7. And they did this unit conversion up here above it just for the neatness factor. So the volume's in cubic meters times, so 1 cubic meter of water, so it's this whole thing, right, has a mass of about 9.98 times 10 to the 5th grams. So that's grams per cubic meter here. And each gram contains 3.34 times 10 to the 22nd molecules of water. So you multiply the number of grams by the number of molecules, right? Which is here, and so that's molecules per grams. So our answers, now that we've done the unit conversion, our answer is going to be in molecules. So now we're just multiplying these three values. So when you're multiplying scientific notation, you multiply the numbers out front. So we have 1.13 times 9.98 times 3.34, and then you multiply the factors, or the base 10s. So 10 to the negative 7th times 10 to the 5th times 10 to the 22nd, and we just learned when multiplying the same base, we just add their powers, or their exponents. So we get, over here, our numbers become 37.7 times 10, negative 7 plus 5 plus 22 gives you 20. So you're left with 37.7 times 10 to the 20th. And a rule of scientific notation is we want to just, like why they did this last step here, we want just one number and then the decimal, and then we can have the tenths in the hundredth spot. But to move that decimal over just one spot is the point so that it's 3.77 times 10 to the 21st. So since you moved it one more spot, you have to add a number to 20, so it's times 10 to the 21st. And if you have questions about scientific notation, we can go into more detail about that, so ask me in class if you have those questions. But you use the same rules of multiplying powers with the same base when you're multiplying scientific notation. So, moving on, exponents can also be expressed as fractions. So these are called rational exponents. So, recall that 3 squared means 3 times 3, and that equals 9, right? And you can write the same expression using rational exponents. So you would write 9 to the 1/2. So I think I touched on this a while ago. This is the same as the square root of 9. Just like 9 to the 1/3 is the same as the cube root of 9, right? So 9 to the 1/2 indicates that, we'll say we had 9 to the 1/2 equals b, indicates that b is the positive number that when multiplied by itself equals 9. So 9 to the 1/2 equals 3, right? So in general, a to the 1 over m equals b means that b multiplied as a factor m times equals a. So b multiplied by itself m times equals a. So all you have to do is, if you're given something like 81 to the 1/4 and it says simplify this, you just have to find the number that when multiplied by itself 4 times equals 81. So in this case it would be 3, because 3 times 3 times 3 times 3 equals 81. So this number multiplied by itself 4 times equals this number. You won't have to do a lot with this without a calculator, so don't panic. It's just good to be aware, at least of the big ones, like 3 to the 4th power equals 81. That's a big number that you should know. So let's just try a few. So go ahead and do these in your notes, and we will talk about them in our next class. And then we're just going to touch on one more thing, expanding this idea to the next level. So if you had 9 to the 3/2 there, instead of just 9 to the 1/2, 9 to the 3/2, that's just like 9 to the 1/2 times 9 to the 1/2 times 9 to the 1/2, right? Because when you have exponents, you're adding the powers or the exponents of the same base, right? And they're just being multiplied by each other, these bases. So 9 to the 1/2 equals 3, right? Because 9 to the 1/2 equals b. What times itself? Just twice, right? So what times what equals 9? Well, that would be 3 equals b, right? So 9 to the 1/2 is 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. So 9 to the 3/2 equals 27. One more example, if you have 64 to the 3/2, well, that is 64 to the 1/2 times 64 to the 1/2 times 64 to the 1/2. And again, be careful that you're writing your exponents small and in the upper right-hand corner of the number, right? So that you're not getting confused with multiplying. And 64 to the 1/2, that's just like taking the square root of 64, right? Or what times what equals 64? So that's 8 times 8 times 8, because 8 times 8 equals 64. And it's to the 3/2. So 8 times 8 is 64, and 64 times 8 is 51. So 512 is our answer. Okay, so now you're just going to try a few and take just a couple more notes, and then you're done. And actually here, you only have to do one. 25 to the 3/2. So solve that in your notes as your next practice problem, okay? So you just need to make sure that these are in your notes, okay? To multiply powers with the same base, add the exponents. And then the algebra line, this one here, a to the m power times a to the n power equals a to the m plus n, where a does not equal 0 and m and n are rational numbers. So that needs to be in your notes. And then write these examples down if you haven't already taken quality examples, okay? And also, if there are questions you have about scientific notation or anything that we've covered, write them down right now so that you can ask them as soon as we get started in class.